Hey guys, welcome to your next video. This one is on objective 7.4a, multiple representations of distance equals rate times time. The EQ is how do I interpret different representations of d equals RT. So this is more so just about looking at different graphs, tables, word problems, equations, and deciphering what they're saying. It's not just directly related to distance equals rate times time. You could do this with a lot of different things. You could do it with y equals kx, like we're learning right now. You could do it with y equals mx plus b, like we'll learn in the future. So it's important to kind of look at these and see exactly what it's asking. So we're going to read the question, use our strategies to underline what's important here. A dolphin travels through the water at a speed of 25 kilometers per hour. All right, that per is going to give us a big hint, okay? Which representation shows the distance a dolphin can travel at this rate? So if you think about per hour, that means per 1 hour, right? So for every hour, that dolphin is going 25 miles. So we're going to look at all four of these different options and see which one looks good. So we've got time and hours, right? So if I said that the dolphin traveled 25 kilometers per hour and it's 0 hours, the dolphin obviously went 0 kilometers, right? So if it was 2 hours, did the dolphin go 50 kilometers? So let's see. If it's 25 kilometers every hour, we're going to multiply that by 2. And obviously that's 50, right? So that is correct. You would do that for all of these. Would 4 be 100? Yes. Would 6 be 150? Yes. Would 8 be 200? Yes. So those are all right. But because we are great mathematicians and we are super good at word problems, we're going to go down and make sure that the rest of them are all right too. So y equals x plus 25, where x represents the time in hours and y represents the distance in kilometers. So if we have y equals x plus 25, let's plug in a number here for x. So let's say we went 1 kilometer, right? Or 1 hour rather. X is time, so x represents hours. If we went 1 hour, we would just be like this. So if we went 1 hour, would that be 26 kilometers? No. It's 25 kilometers, right? As you can see at the top, 25. So B cannot be correct. So distance traveled by a dolphin, we're going to look at this graph. And again, yes, you are drawing all of this, writing it all down. So distance traveled by a dolphin. So it looks like it's going up 25 every hour, right? So I guess we're good. Oh, but wait, let's look at this here, because this is the type of thing that's going to mess most of us up. So we didn't read the graph very correctly because Mr. Brous just said, yep, it looks good. But look here, we've got time is on the x-axis. So this is basically saying for every 25 hours, we're going 1 kilometer. That's like a snail, guys. That's not a dolphin. So this one would be wrong because the x-axis and the y-axis are not correct, right? They're switched. So if these were flipped around, then yeah, we could absolutely say that that's correct. But it's very important to read everything, okay? So that one can't be correct. And in 5 hours, a dolphin can travel 135 kilometers. So we know that it's distance, rate, and time. So if we're going to plug this in, we know we're saying 5 hours. So let's see how far this dolphin could go in 5 hours. So if it's 5 hours is the rate, or the time rather, and the rate is 25 kilometers per hour, we're going to multiply those, right, to find the distance, to see if this is correct or not. So 25 times 5, 5 times 5 is 25. That's 10, 11, 12. So that's 125. So that's incorrect as well. So our answer is actually A. So I think the important thing is here just to read over it very carefully. Make sure you understand what you're actually looking for, because we can make careless mistakes. It could be the difference between getting masters on the STAR test and not.